Okay, welcome to this series of client-server lectures. Uh, so far, we have spoken about the communication between client and server. We talked about the inter-process communication last time. Today, I will speak explicitly about an example that you have already seen in the sessions, in the lab sessions, which is called the Echo server. Okay. The Echo server, what we mean by that is this is a client here, as you can see. Client send a message to the server, says, my name is Mohammed. The server will echo the message and respond with, my name is Mohammed. So in reality, the way this goes, let me take this a little bit down so you can see that clearly. Okay. What happens is like this. This is my client again. That's my server. So the client will put the message hello. So let me take now the message is hello rather than my name is Mohammed. I want to echo this hello. What exactly goes on? The client will take this hello, will put it in the out stream. This is the output stream. Remember that the output stream, as you have learned in the session, is the means to put a message in using the output stream to take this message and put it in the CS socket. So the client socket, which we call and here I represent that with one single port, although I have already spoken that this socket actually looks something like this. Okay, the socket, as I said, it looks something like this. So if these are my sockets, if you will. Let me line this up so fast align left. Okay, so these are my sockets, and usually this is my port. So this is my port, and the port usually is connected to one or more, depending on how many sockets I create. I create this socket and this socket, so there will be multiple sockets created on. So when I say the port, client socket port, actually I mean one of these sockets. Okay, that's just to make sure that we stay connected to the notion of a socket versus port. Anyway, so here is the client. The client writes the hello into out. Out goes into the client socket. Now, once it goes in the socket here, from this time on, let me introduce the following term for you. And actually, let me create a new slide. And I will call this the communication process using TCP. Okay, what I mean by this, you say write hello into out called variable. This is what I said by the IO or output stream. So you know how to do that already. Now, from the hello, we'll go into the socket. This is processing time. I will call it processor time. So this is the processor will take this data from the socket into the port. Hello, from the socket to the physical port. No. Now, from this time on, the TCP stack takes over. So from this time on, it's no longer my programming. It's the programming which has already been done at the OS level or at the communication level. This is called the TCP stack. What the TCP will do, it will take the word hello, take it from socket, which is the memory location, to physical port. So this is step number 1. So now the TCP will be responsible for allocating the socket to the physical port. And here I have to mention that there will be scheduling delay time, which means, what I mean by that scheduling delay time, I mean that by that if there are other clients trying to send message, then the TCP will arrange for a time for each client, which means راح يعطي دور لكل client بالدور ليجي دورك انت بعد delay time or waiting time بخليك تبعث المسج تاعك. So once this is done, okay, so the hello now goes into the socket. Now from the TCP will take the hello message. Now hello message, and will break it into packets, because this is how the TCP IP protocol works. It takes the hello message, it divides it into packets. Now for this simple word hello, it will be only one packet, and the packet is around 1 kilobit. So it's not usually you don't the hello now will not fill the entire packet, but nevertheless you will use one packet to transfer it. Usually each packet contains the message itself, which is the word hello, okay, of course in binary. So this hello will be probably, you have 1, 2, 3, 4, 5, assume it's about 40 bits, and it will use the headers, for which will include remote address, where am I sending the package, will include the remote port, where am I sending which port I'm going to access. It will include also the local, or the sender, which is actually, let me call it the client IP address. When I said here the remote address, I will say, actually let me repeat that, server IP address, the client IP address, client port. That's for the return, in order for the server to be able to return the response to the client. So the TCP will take care of this. It will create a packet and this packet will have the message, will have the header, which has the IP addresses and the remote ports, and maybe some other security information which are not the subject of this course. So let me show one more slide for this, how this will be. So so let me call this or actually let me do it this way. So the TCP protocol will receive my message from the socket. This is socket. Will take the message called the hello, and TCP protocol will create packet. This is now I will mention in a second that if the message is more than hello, then it will be let me use this more better notation. I'll call it create packet. Okay. So the TCP will create the packet. Range, align middle. Okay. So in the header here, I will have the server IP, server port. Actually, let me do it differently so we know exactly what we are. So assuming that the server port, server IP address is 78.22.1.5 server port, assume it is 1025. Remember, 1025 is not reserved. Client port, let's say it is 212.34.4.76. Client port, let's say it is 1035. Okay, so if this is the case and of course the word hello. So the packet will look now, I will use the decimal numbers, but those should be in different, will be in binary. So let me use the dash as 00, well, dash dash, then 1025, then 212.34.4.76 dash dash 1035, and then dash dash hello dash dash, and then there will be some more bits here. This will be filling bits so that you can fill the you can fill the packet. So this is our packet. So the TCP create a packet. Now this packet has to be transferred over the physical line. Here is what I've said here. This is the line that goes from the client to the server. This is the line that comes back from the server to the client. This could be wireless, could be Bluetooth, could be wired. It can be anything. So here, let me visualize this. So this is my client now. Again, it's my client. And this is my port. On the client side. So the packet now is sitting no. So the TCP, which is actually sitting on the client, the TCP protocol is on the client side. So this is the TCP protocol is part of the software stack which sits on the client. It prepares the packet and puts it on the port. So now this packet is ready to go on the channel. This is our so this is my channel. Let me put it in yellow color, and it should come to the that's my server port. Okay, so this is port number from the client 1035, port number 1035. This is port number 1025, and this is the IP address the client is 212.34.4.76, and this is the IP address 78.22.1.5. Okay, so now what happens is that for this packet to go into the line now, which means to leave the port, okay, we said that the TCP is responsible as a stack to create the packet. Now also the TCP protocol would be responsible to do the transfer the packet from the port to the physical line. Physical line means could be Wi-Fi, could be Bluetooth, could be wire, could be anything. Okay. Now let's say, assume that we will using Ethernet. Now for the Ethernet, of course, it will the Ethernet protocol to transfer using Ethernet to transfer packet from port to physical line, which is now putting the packet here. Let's make it more visible. Okay, so I put the packet on the channel. For this packet to go on the channel, what happens is that this is called the data transmission, which means transfer packet of data from the port to the physical line using the Ethernet Okay, so this is the process now. See, the client uses of course, as I put it here earlier, I write hello into the out variable, which is this one right here. So going back to this, so now the hello goes into the out comes to the client socket port. The TCP IP will take it and put it as a packet. Now the hello will be transmitted to the physical line. This is called transmitting data transmission. Then it will proceed over the link here, whether it's the wireless or wired or the Bluetooth. It goes all the way to the server side socket. The data will be received as packet, will be received by this the server socket, and will be transferred from the line from here. So there is here Let me visualize it as put it in red. So this will be the actual transfer, and here let me put it this way. Okay. No, this way. Transfer data from link to server socket. Okay, so this process here, we're transferring the data from the link to the server socket, and similarly we transfer the data here from client socket to link. Okay, that's what I've done here. Now the question, I need to ask the question. Let me put a new slide here. Okay, oops. Let's change the layout. What are the time calculations here? The first time, and let me bring the slide here. Oops. Now I don't want that. And okay. In the process, what is the time involved? Let me see if I have the slide here. I think I do. I don't need this now. Okay. Okay. So I have write hello into out into the port, the socket into the physical link. Hello goes over the physical link. From the physical link go to the socket. From the socket goes to the N here. From the N goes back to the out. From the out, writing back the word hello into the server socket and then back to the client. So let's follow this procedure step by step. And this will be the subject of the next video. I already have enough here.